So, let us look at the Prevost reaction mechanism. We will just go through textually what are all the things, then we will exactly look at the reaction mechanism in detail. So, first is the addition of iodine to the alkene to produce a cyclic iodinium ion. So, this is the first step. Then we are using the silver salt. So, the silver salt actually gives the anion, and that anion is actually the nucleophile which adds to the iodinium ion. So, this happens later on. So, we have a positive charged iodine which is present in the first step, and we have a negative charged carboxylate anion is there. So, the negative and the positive, they actually interact with each other, and then in the next step what happens is we have added the corresponding salt. A carboxylate anion was added. So, the carboxylate anion has a carbonyl unit. So, this has a oxygen, carbonyl oxygen is present. So, this carbonyl oxygen internally attacks the carbon with the concomitant loss of the iodine atom, which gives a cyclic intermediate, and there is a second anion, that is the benzoate anion, attacks the cyclic intermediate from the opposite side, leading to the opening of the intermediate to produce the anti-substituted dibenzoate product. So, of course, these are looking too much textual. When we look at the reaction mechanism, you will understand. And finally, the hydrolysis of the intermediate leads to the transdiol. So, let us look at the reaction mechanism through schematic diagrams. So, this is our starting alkene, and the first step is the addition of the iodine. So, this leads to a cyclic iodinium ion intermediate. So, this is the step 1 which is formed, and as we mentioned, we have the corresponding carboxylate salt which is present, which is getting converted to the carboxylate anion. So, this carboxylate anion can attack any one of the carbon atom. So, here in this particular case, let us look at if it adds to this particular carbon, then the cyclic iodinium ion opens up, and we end up with the iodine attached to one of the carbon atom, and the carboxylate unit being added to the other carbon atom. So, this is how the addition takes place. So, the first step is the addition of iodine, followed by the opening of the cyclic transition intermediate by the base, that means the nucleophile which is the carboxylate anion, and we end up with this particular product. And once this product is formed, we have a carbonyl unit present in this one. So, this is having a lone pair of electron. So, this is the nucleophilic site, and this nucleophile now attacks this carbon which is having the iodine atom. So, when it attacks this, iodine leaves as a iodide minus ion. So, I minus is lost in this particular step, which leads to the cyclic benzoxonium intermediate as shown here. So, this is the crucial step which is happening in this particular Prevost reaction mechanism, and now this particular carboxylate anion, because in the reaction we have plenty of carboxylate anion present. So, this particular carboxylate anion now attacks one of the carbon atom, and when the this is attacked, this opens up to give the corresponding ester derivative as shown here, and there is also another ester which is being added from the other side. So, if you look at the addition, the second addition of the carboxylate and the first addition of the carboxylate both actually occur in the trans position only. So, in the first step, from the addition takes place opposite to the iodinium ion side. Okay. So, this is the first trans addition, and when the cyclic intermediate is formed, the second carboxylate ion attacks from the opposite side, from the trans side. So, we have the carboxylate anion attached from both the opposite sides of this compound, and the hydrolysis using a strong base hydrolyzes the corresponding carboxylate, and we end up with the corresponding diol derivative. So, in this particular case, we end up with a trans addition, because the second carboxylate anion attacked this cyclic intermediate from the opposite side or the trans side. So, this leads to the corresponding trans product in the Prevost reaction mechanism or in the Prevost reaction.